Hi everyone, in today's lesson we're going to talk more about solving systems of equations. This time we're going to solve quadratic linear systems. So when you solve a quadratic linear system, you are solving for the points of intersection, this time between a quadratic, which is a parabola, and a line. So there are three scenarios that could arise. You could have two solutions, one here and one here, right, where it intersects. So let's label that beneath here with two solutions. You could have a scenario where the parabola and the line only intersect in one point, so you could have one solution. Or you could have the scenario where the lines never intersect and you have no solutions. So in order to decide which equation is which, we need to recall that quadratic equations are in the form y equals ax squared plus bx plus c, and all lines are in the form y equals mx plus b. So really the main difference to decide is if I have a squared, it's usually a quadratic, and if I just have a regular x, it's a linear equation. So what we're going to do algebraically is find and solve the systems of equations. So notice this first one is in y equals mx plus b, and our second one is in y equals ax squared plus bx plus c. So it helps us to know that this one is our line and this one is our quadratic. So the way we're going to solve this is because they're both set equal to y, we're going to set them equal to each other. So step one, set equal to each other. So we have 3x minus 6 equals x squared minus x minus 6. And we solve. Now the way that we solve, when we have an x squared, we need to set it equal to 0 so that we could factor, t-chart, and solve. So minus 3x on both sides and add 6, minus the 3x with the x and add the 6 with the 6. So now these cancel. We have 0 equals x squared, and then negative 1, and then negative 3x will add to a negative 4x, and negative 6 plus 6 actually will cancel out as well, so we just have this terms. So when we factor, we would always try for our first step of factoring, which is GCF, so we can divide both by x. So when I do x squared divided by x, I subtract the exponents. So 2 minus 1 is 1. And then when I do 4x divided by x, the x's will cancel, and I'm left with minus 4. And then we do a t-chart. So we have x equals 0 and x minus 4 equals 0. We can add 4 to both sides, and 0 plus 4 is 4. So just to visualize what you solved for, you've got your quadratic and you got your line, and it looks like we have found the x values of the points of intersection. So this is x equals 4, y equals something. This is x equals 0, y equals something. So in order to finish this, we need to find the y values. So the y values, step 2, you can plug into either one of the original equations. I'm going to choose to plug into the line because it's a little bit easier. So we've got y equals 3x minus 6, and we're going to plug in our x value. So let's try 0 first. So 3 times 0 minus 6. 3 times 0 is nothing, and we're just left with negative 6. So to make it a point, you've plugged in 0 to be our x value, and you got y to be negative 6. So that's my first point of intersection. Now we're going to do that again. Y equals 3x minus 6, but this time we're going to plug in 4. So y equals 3 times 4 minus 6. 3 times 4 is 12. 12 minus 6 is 6. So your point, you put in an x value of 4 and got out a y value of 6, so it's 4 comma, 6. So those would be my points of intersection. So if you want to write the steps down over here that we did when we had an x squared, we had to set it equal to 0 to solve, and we had to factor and make a t-chart. So if you need those steps, feel free to write them down. All right, let's try another example. So here we have example number 2. So notice in example number 2, it's not y equals this and y equals this. So what I would suggest that you do as step 1 is set both equations to y equals. So in this case, we have 5 equals y minus x. So to get y by itself, I can just add x to both sides. So I get y equals x plus 5. We can't add them and make it 5x, right? Because they're not like terms. And you could write it as 5 plus x if you want, but I chose to write it as x plus 5 to keep it in mx plus b form. Okay, the next one, we have 4x squared equals negative 17x plus y plus 4. So I'm going to add the 17x and I'm going to subtract the 4. So then I will get, if I put it in order, ax squared, so the 4x squared, plus 17x, and then minus 4 must equal y. So now that this is in y equals and this is in y equals, we can do exactly like we did before. So step 2 this time is going to be set the equations equal. So we've got this equation, y equals x plus 5, and we have this equation, y equals 4x squared plus 17x minus 4. So let's do that. We have x plus 5 equals 4x squared plus 17x minus 4. So remember, we have to, if we have an x squared like we did before, we have to set it equal to 0 so that we could factor, t-chart, and solve. So we're going to minus x and minus 5. So we've got 0 equals 4x squared. 17 minus 1 is a positive 16. And negative 4 minus 5 is your negative 9. So if you want to write down the step that we did here, we set it equal to 0. And now we have to factor. So you should notice that we have a trinomial here. A trinomial has 3 terms. And you should also notice that the leading coefficient, or the number in front, is a 4. It's bigger than 1. So we're going to have to do AC. So remember, AC is we multiply the first and the last. So 4x squared times negative 9. If you put that into the calculator, 4 times negative 9, you should get negative 36. So negative 36 divided by x, that's what we're going to put into our y equals, and we're going to get a table of values. So take a minute, put this into the calculator, get your table of values, and hit resume when you're ready. Okay, so you should have 1 and negative 36, 2 and negative 18, 3 and negative 12, 4 and negative 9, and 6 and negative 6. So we're looking for a pair on this list that's going to add to 16x. So I see 2 and 18. I see that that actually adds to a negative 16. So I think I can flip-flop this list, and I also could have a negative 2 and a positive 18. So I think this is the pair that I want. So negative 2 and positive 18. So remember, we're splitting this middle value, 16x, so that it results in these two. So we need an x and an x in order to make it 16x. So we've got 4x squared minus 2x plus 18x minus 9. So you see how the negative 2 and the positive 18 will add to a 16x. And we have this set equal to 0. And remember, when we have 4 terms, we factor by grouping. Group the first 2 terms, group the second 2 terms, and bring down the sign in the middle. So the GCF of the first 2 terms looks like 2x. So 4x squared divided by 2x, 4 divided by 2 is 2, X squared divided by x is 2x, and 2x divided by 2x, anything divided by itself, is 1. And the GCF between 18 and 9 is 9. And 18 divided by 9 is 2, so 2x. And then 9 divided by 9, anything divided by itself, is 1. And now that these parentheses are the same, that's what I'm looking for. So that becomes its own parenthesis, 2x minus 1. And the stuff on the outside we put here as my second parenthesis. So 2x plus 9. And we're setting this equal to 0 still. And we're going to do our t-chart, right? So now this is step 3, t-chart. So we're going to set each piece equal to 0. So 2x minus 1 equals 0. Solve, adding 1 to both sides, dividing by 2. So x equals 1/2. Take your 2x plus 9, set that equal to 0, and quickly solve. Subtract 9 on both sides and divide by 2. So x equals negative 9/2. So remember what you just did, you've got a quadratic and you've got a line. So you found one of the values for x to be negative 9/2. We need the y value. And we found the other value to be 1/2, and we need to find the y value. So step 3 is going to be plug in x values to find y values. Now, again, I always like to plug into the line. So if we go all the way back up to the top, here is our line. I think this one's a little bit easier. Y equals x plus 5. So we've got y equals x plus 5 over here, and y equals x plus 5 over here. And we're going to plug in this value for x, and then this value for x, and we'll find our corresponding y values. So y equals 1/2 plus 5. So I'll just tell you what this one is. It's 11 over 2. So again, you plugged in your x value of 1/2 to get a y value of 11/2. So that is your first point of intersection. Now our second y value, which is negative 9/2, which we're going to put here, and we're going to add 5. And again, I'll just tell you what this one is. This should be 1/2. So the point, you plugged in x to be negative 9/2, and you get out the y to be 1/2. So that should be your final answer. All right, that's it for today. If you guys have any questions, please jot them down. Otherwise, we'll see you in class tomorrow. Have a great day.